Assalamualaikum and a very good day. My name is Muhammad AUFA bin Muhammad KHAIRUL LIZAN and my metric number is 209281. Me and my group members from Group 10 will be presenting our mini project about digital voltmeter using dual slope integrating type digital voltmeter. First of all, I would like to introduce all the group members, which are SYAHMI bin AZHAR, Muhammad SYAHIR bin SAYUTI, NABIL bin ACHMAD NAZEEM, Muhammad RAHIM bin Muhammad BASRI, and me, Muhammad AUFA bin Muhammad LIZAN. And lastly, our lecture of Instrumentation and Measurement course, which is Professor IR Dr. Suhaidi bin Shafi. In this mini project presentation, we will talk about the introduction, objective, methodology, simulation result, advantage and disadvantage, and lastly the conclusion. I will start by explaining what this project is all about. Measurement device known as digital voltmeter systems transform analog digital signals into digital or numeric readouts. An electric voltmeter that monitors and displays DC or AC voltage as discrete integers rather than a pointer deflection on a continuous scale is known as a digital voltmeter. For this particular mini project, the type of digital voltmeter used was dual-slope digital voltmeter. Significance in accuracy can be produced by overlaid noise in RAM technique. In the dual RAM technique, the integration of the positive and negative RAMs average out the noise. Therefore, the dual slope digital voltmeter was able to average the noise and reduce the error. The objective of this mini project are first, to increase our understanding of the working of digital voltmeter. Second, to learn the application of digital voltmeter in electric circuits. Third, to learn more about the conversion of ADC within the dual slope digital voltmeter. And lastly, to be able to simulate the digital voltmeter circuit.
Okay, so hello, my name is KHAIRUL and for my part, I will explain about the methodology. Okay, so as we can see here, we have a block diagram of dual slope digital voltmeter, which consists of bunch of component in it. Okay, so the input voltage Vi is integrated using digital voltmeter of the dual slope integrating type. So basically, the input voltage Vi we supply will integrated by digital voltmeter of the dual slope. Okay. After that, the input voltage under measurement will affect the integrated signal slope in a direct proportion. So in a simple term, the input voltage Vi that we want to measure will affect the integrated signal. Okay, after that, after a certain period of time, for example, we choose T1, the supply of input voltage Vi is stopped and a negative VR of the integrator is applied. So in simple words, when we reach a certain time, the Vi will off and the negative VR will on. Okay, after that, the output signal of the integrator will experience a negative slope. So there is a important building block that we should know, which is op-amp employed as integrator, which we can see here, the integrator part in the block diagram. And next, level comparator and oscillator for generating time pulse, a decimal counter, which we use the decade counter here, and a block of logic circuitry, which we use the control circuit. Okay, so I think that's all for my part. Thank you.
Moving on to the simulation result. This figure shows the digital voltmeter circuit with an LED display. The circuit using the ICL7107 from Intersil. The ICL7107 is a high performance, low power and 3.5 digit analog to digital converter. The IC has internal circuitry for 7-segment decoders, display drivers, clock and a source of the reference voltage. The ADC used in ICL7107 is a dual slope type ADC. then the power dissipation is under 100 milliwatt, and the display stability is quite high. Using the design guidelines provided in the data sheets, and we created a simple 100 volt DC voltmeter, and it shows 3 digits with a 99.9 volt maximum. And the reference voltage of 100 millivolt is generated using 1.2 volt Zener and variable resistors from a voltage divider. So for the simulation in Proteus software, we use this to represent the voltage, the reference voltage. And the input is divided by 100 kilo ohm and 100 ohm resistor to get 200 millivolt in proportion. So pass to the next member to continue the presentation.
Okay. Assalamualaikum. My name is Muhammad SYAHIR and my matrix number is 2057F10. Moving on to the advantages of this dual slope digital voltmeter. The first advantages is it has excellent noise rejection, as noise and superimposed AC are averaged out during the process of integration. The second one is the RC time constant does not affect the input voltage measurement. The sample and whole circuit is not necessary. Third is the accuracy is high and can be readily varied according to the specific requirements. And the fourth is it indicates a negative quantity when the terminal polarity is incorrect or reversed. And the last advantage is it is not usually damaged by rough treatment. So moving on to the disadvantages. Okay. The first disadvantage of this dual slope digital voltmeter is that the speed of the digital voltmeter is very slow as compared to the other digital voltmeters. Okay, and it also generally more expensive compared to the analog voltmeters that we currently have. So I think that's all from my part. Thank you.
Thank you, Syahir, for his wonderful insight on the advantages and the disadvantages of dual slope digital voltmeters. Before we end our presentation, I, Nabil NAZEEM, would like to conclude our findings on the study of this voltmeter. In a nutshell, the ADC used in the simulation process using Proteus is a dual slope type of ADC. The dual slope integration digital voltmeter eliminates the requirement of precise ramp voltages and time periods. These two parameters are very hard to maintain, and they are the requirement for other types of digital voltmeters, especially for the ramp voltmeter. However, for dual slope digital voltmeter, they are ignored due to the functionality of integrator in the circuit. The integrator capacitor is charged from the analog input voltage, which then discharges at a constant rate and is measured digitally. It is important that the dual slope integrator digital voltmeter has a reliable constant current source. The voltmeter is easily calibrated by applying a known input voltage and adjusting the constant current source to produce an output reading equal to the applied voltage. If the clock generator frequency drifts, it can alter the T1 and T2 period in proportion, but it does not affect the accuracy of the measurement. With that, our group would like to say thank you for listening.